Hello and welcome back to the course. In this segment, we will be looking at some more math functions that you can use in MATLAB. The first function that we will be learning is the GCD function, which is going to compute the greatest common divisor. If we provide two numbers to this function, then it is going to compute GCD of those two numbers. Alternatively, if we pass to it a matrix containing many values, so for instance, I want to pass it a matrix containing 4 values and another matrix which also contains 4 values. Suppose we include values of 10, 30, and then 100, and finally 180. So now if we pass these two matrices to the GCD function, it is going to work and it will return a matrix that is of the same size as that of the input matrices. The very first thing we should note is that the input matrices have to be of the same sizes if we are passing it to the GCD function. And then the output is also going to be of the same size as that of the input matrices. The second important thing to note is that it is performing GCD element by element of the two matrices. So for the first number in the matrix and for the first number in the second matrix, their corresponding GCD is over here. For the second two numbers, their GCD is 10. Similarly, for the next two numbers, the GCD is here. And finally, for the last two numbers, GCD is over here. Another alternative way in which the function GCD may be used is we may pass to it a number and a matrix containing multiple values, and it is going to compute the GCD of 10 in this case with each and every element of the matrix A. So these were a few variants that you can use for the GCD function. Similar to the GCD is the LCM function, which is used to compute the least common divisor. In the simplest form, this function can be used by passing to it two numbers and it will return their corresponding LCM value. Now let us learn some of the different variants of the same LCM functions that are very similar to the GCD function. Let us compute the LCM of a number with a matrix. So in this case, it is going to compute the LCM of 10 with each and every element of the matrix A individually. And similarly, you can also compute the LCM of two matrices in the same way as we computed it with the GCD function. Now let us learn the isPrime function, which is going to tell us whether or not a certain number is a prime number. For instance, if we pass to it a value of 8, it will return a value of 0. Please note that the value this function returns is of type logical. Alternatively, you may pass to it an array or matrix containing multiple values. So for instance, if we pass to it the matrix that we have previously defined, so it is going to return a matrix of type logical, which will contain zeros for the elements which are not prime and ones for the elements which are actually prime. Let us define another one which will contain 9 values. And now if we call the isPrime function, so for the first number there is a 0, which means not prime. For the second and third values they are primes, and so on. Another closely related function that I want you to learn is the primes function. If we specify with this function a number such as 25 in this case, then it's going to generate all the prime numbers that are less than or equal to 25. In this case, it has given the following values as prime numbers. If we mention some other values such as 30, so now the primes are up to 30 and the highest prime that is less than or equal to 30 will be displayed. Next, we learn another basic math function, and that is the prod function. If you pass to it a matrix, then this function is going to compute the product of all the values that are there in the matrix. For instance, prod A is going to return this number, which is computed by multiplying all the numbers in the matrix A. So basically it is computing 1 times 2 and then 2 times 3 and so on. The next function that we are going to learn is the perm functions. that is perms with s. Remember that there is an s with the perm. This function is going to compute the permutations of the numbers that you pass to it in an array or a matrix. So for instance, if we pass to it these three values, then it is going to give us all the possible permutations of these three numbers. That is the first permutation, second one, and so on. In this case, it has generated 6 different permutations. If I add another number in the matrix, now the number of permutations are going to increase significantly. So it is giving us all of our permutations that are possible for the values in this matrix. Please note that if you give it a matrix of more than one row, for instance, if you give it a 2 cross 2 matrix such as this one, then it's going to treat all the values as a single matrix and will give you permutations for all the values. Remember, we need to put an s after the perm. So we see that it is giving us all the permutations for all the values that are there within the matrix. So this essentially means that it is not treating the individual rows or individual columns separately. Rather, it is treating all elements that are within the matrix as a single matrix elements, and it is creating all the corresponding permutations for that. With this, we come to the end of this lecture. We will be covering more math functions in the upcoming lectures. Do come back to cover those, and until then, enjoy MATLAB!